So this chart is showing how it is and what uranium does when it goes through the series of things that it decays into. All right, so not only do we get alpha particles out, because of getting alpha particles out, it's not uranium anymore. Okay, let's look at that. So the first thing uranium-238 does is it gives away an alpha particle. Okay, so that little angled arrow is telling you what's happening with the alpha particle. What it means is that we started out with a mass of 238, and because we gave away an alpha particle, the mass drops to 234. Why did the mass drop to 234? Taking away a mass of 4. That's where that 4 is right there. Okay? But we're also changing the atomic number. We go from 92 to 90 because we're giving away 2 protons. The alpha particle has 2 protons, 2 neutrons for a mass of 4. So the mass goes down by 4. The atomic number goes down by 2. Okay? Now this is just showing the process. We're going to write a nuclear equation to represent that process. So here is uranium-238. The mass goes at the top. The atomic number goes at the bottom. And this is going to give away, first, an alpha particle. What does an alpha symbol look like? Huh? Well, some would call it a fish. What? I like to say it's an A with a swish at the top. Okay. What else do we put on the nuclear symbol for an alpha particle? Huh? 4-2. You've got to have the mass, yes, and the atomic number there. Okay. All right. If I give away a mass of 4, we're going to have something else left over. We're not giving away the whole uranium atom or the uranium nucleus. We're just giving away the alpha particle. So if I have a mass of 238 and I give away a mass of 4, there's something else we're going to have over here. What mass will it have? 234. And if I have an atomic number, which is the number of protons, and I give away 2 protons, this is this atomic number here, what is this particle's atomic number going to be? 90. Okay, so what element has an atomic number of 90? What element has an atomic number of 90? Thorium. You just look on the periodic table to find it. Well, this is how you write a nuclear equation to show the alpha decay of uranium-238. And there's different isotopes of uranium. This one happens to be uranium-238. Okay, the more radioactive form of uranium is 235, so I'd have a 235 up there if it was uranium-235. And if I wanted to build a nuclear bomb, I'd want at least 4%, probably more, uranium-235 compared to 238. What? We just have to know that alpha has a mass of 4 and an atomic number 2. You just have to know it. Now, thorium doesn't just stay thorium. Okay? Thorium is also radioactive. Every element that's larger than number 83, which is bismuth, every element that's larger than 83 has no stable isotopes. All the elements that are larger than element number 83, which is bismuth, have no stable isotopes. They're all radioactive, and thorium is larger than 83, so there's no stable form of thorium. So it's going to go through some kind of nuclear decay. Let's look at that. Let's look at the chart. Look at the key down here and see if you can figure out what kind of decay thorium goes through. Look at the chart, use the key at the bottom, and look at how things are going on here. This is the uranium alpha decay right here, this first step. What is the kind of decay that thorium goes through? It goes through beta decay. Okay? And beta decay means I have to have, if I'm going to write a nuclear equation, I have beta here. And what's the atomic mass of a beta particle? 0. And what did we say we're going to use as the atomic number for a beta particle to make the math work out when we were first looking at this? It wasn't 1, negative 1. You just have to know. How did he figure out it was beta? Well, because down here it says a beta is an arrow to the right this long, and there is a beta to the right that long. Okay? That's just figuring it out from the key. Alright. Okay, so I've got, listen now, here's how you figure out how to balance these equations. It's really, really simple. The sum of the mass on the right must equal the sum of the mass on the left. Okay? Also, the sum of the protons, or atomic number, on the right must equal the sum of the protons on the left. So balancing nuclear equations really isn't hard if you can add and subtract. Okay? So I've got 234, that's the total mass on the left, and I've got to have the mass on the right come out to be the same. 234. Very good. How about the mass on the bottom? I mean the atomic number on the bottom. 91. 91 plus a negative 1 would give us a 90. Right? So what element has a atomic number of 91? Very good. Very good pronunciation. Protactinium. PA. Got that? Sum of the protons, which is also the atomic number, that's why I put it in parentheses, on the right must equal the sum of the protons on the left. The protons are always the numbers at the bottom. That's the atomic number along the left, bottom left. Okay? All right. So uranium goes through an alpha decay. Or after uranium doesn't. The product is thorium that goes through alpha decay, and we get to protactinium here. Then what does protactinium do? Another alpha decay. Write that equation. Protactinium 234 goes through alpha decay. You know that by looking at the decay series here. Finish the equation, or write the equation now. How about that? So it isn't that hard. Okay? Alright, so when we have this decay, protactinium goes through beta decay, you'll get this particle as well. Well, look at the chart. Uranium-234 doesn't sit still either. What does it do? Uranium-234 doesn't sit still. What does it do? Alpha decay. Let's write that equation. Write the equation, the nuclear equation for the alpha decay of uranium-234 now. Two different isotopes of uranium. We've got 238 up here, now we have 234. Okay, we have thorium-234 here. Let's see what we get from this decay from 234. Another isotope of thorium now. Okay, so all of these are types of nuclear equations. All of these are types of nuclear equations. Well, 234 on this side has to equal the sum of everything across the top. So if we have an alpha decay, then this must be 230, so the sum 4 and 230 equals 234. Okay?